All right. What page was homework? Thank you. 161, 162. I think we should go through them both. What do you think? Is that okay? Anyone opposed? I'm going to dim the lights so you guys can get background. All right. So let's take a look. You have it out? So problem number 1, we have f of x is equal to 4 times 1/2 raised to the x. Okay, so what sticks out on this problem to say it's exponential? What is making it exponential? X. Well, x where? As a power. Good. X as a power is what makes it an exponential function. Okay, so I'm going to sketch the graph and then we'll see how we can answer these questions. I'm going to plug -1, 0, 1, and 2 in. Is that okay? -1, 0, 1, and 2. And the reason I'm plugging those in is that's where they want us to find the rates of change, right? Plus, those are kind of nice numbers to plug in, I think. Okay, so follow my math on this. If I take -1 and plug it in, that flips 1/2 over to 2. And then 2 times 4 is 8. Is that okay so far? And I'm going to actually zoom this out a little bit. That should be good. All right. And let's plug 0 in. 1/2 raised to the 0 power. It's 1. 1 times 4 is 4. Okay. Plug 1 in. 1/2 to the first is 1/2. What's half of 4? 2. 2. And then take 2, plug it in. 1/2 times 1/2 is 1/4. 1/4 times 4 is? Yeah. Okay. Okay, so let's take a look at this. -1, 8 is like way up here. Oh, hey, before I go any further, what's my asymptote? 0. It's because there's nothing back here, so there's like a +0 here. So here's my horizontal asymptote right there. Okay, good. All right, so 0, 4 is here. 1, 2 is here. 2, 1 is here. And then this is just going to continue on a downward. So this is what this graph looks like. Does that seem okay? You guys are done? All right. I will take you on and look at it now. All right, all right. Here, that didn't show up good.
Yes, I'm
Yeah, I'll put your grade into 6.
Thanks, Sarah.
Yeah, buddy. And your grade's going to reflect it in about 10 seconds, maybe 15.
And he's a good person. I haven't talked to him in a long time.
K-R-I? Maryland relates to you? Oh, yeah. Mariel.
Yeah.
She's Jackson's sister? Older, younger? Dude, 90%? Alright, great. Change your grade right now, too. Yeah, buddy. Good job.
Don't worry about
Thanks, Mr. Yeah, buddy. And your grade's updated now. All right. Sorry about that. So does everything up here make sense so far? All right. So sketch the graph. We got it. What is the y-intercept? Well, the y-intercept is 0, 4. Perfect. Okay. What equation of the horizontal asymptote? Y equals 0 is that. Okay. If there was a number out there, it'd be whatever that number is. All right. And then remember, with rate of change, we have to do the slope equation. Remember this equation? Okay. So let's take care of these two first. Is that okay? And remember, this is the calculus in the class. Yeah, baby. All right. So 4 minus 8 is negative 4. And then 0 minus 1 is 1. So this has a slope of negative 4. So from negative 1 to 0, this slope right here, that has a slope of negative 4. Hey, does that make sense? That's a negative slope. Is the line pitching down there? Yeah. Okay, then let's find the slope of this one. And stop me if you're confused on that. Okay, so let's make sure we can do this one. 2 minus 4, negative 2. Agree? 1 minus 0 is 1. So I get a slope here of negative 2. So from between these 2 points, my slope changes to this. So then I get a slope of negative 2. And does that still make sense? It should be a negative slope. It's pitching downward, right? And then the last one, these two. So I get 1 minus 2 is negative 1. 2 minus 1 is 1. So I get a slope of negative 1 up there. And so from 1 to 2, that is negative 1 of the slope. Cool. And let's see what else. What did we notice about the rate of change from E to G? Well, it's definitely changing. The slope is changing as we move along the graph, which is great. Is this an exponential growth or decay? Ooh. What do you think? It's going to the right. Where does my graph go as I go to the right? It's decay. It's definitely decay. The reason why it's decay, the Algebra 2 answer of why it's decay is as my domain increases, the function at x approaches the asymptote. Okay? The Algebra 1 way is as I go to the right, it comes close to the asymptote. Doesn't grow away from it. So, cool? And then they wanted us to find, this was kind of thrown in there. I was surprised to see this, but let's see if we can do it. They want, what is f at 2? Well, when I plugged 2 in for x, what did I get out? When I plugged 2 in for x, what did I get out? 1. Done. That's the whole problem. Yes?
Wait, so what is E and G? What do you notice about rates of E?
It's changing as I go to the right, it's changing.
So what's E and G?
So E would have been the black one, F, G. It was just finding the rate of change, which is the slope.
Okay.
So I guess mathematically you could say as my domain increases, my slope approaches 0.
So can we just say like it's changing? Is that
It's changing sounds perfect to me. it's not the same. It sounds good to me too. You like that?
Yeah.
All right. Oh, and I got graded your test. It's in the from yesterday. Thanks for coming in.
Thank you.
Let's go to problem number 2. Backside, yes? Number 2. F of x is 3 raised to the x minus 4. Okay, so item number 1 is this exponential.
Yes.
Why? Tell me. Because my exponent, the x is my exponent, something like that is perfect. I like that. I like that a lot. Okay. Speaking of that, where is my horizontal asymptote on this problem? Y equals 4. Love it. Negative 4 right here. That right there indicates I have this right here. And so let's just mark that down. That's the line y equals negative 4. Because y equals the numbers horizontal. Okay. And I think we're going to use the same values to plug in. Negative 1, 0, 1, and 2. Does that seem about right? Looking at D, E, and F. 0, 1, 1, 2. Is that it? Okay. All right. Let's see if we can walk through this. I'm going to take negative 1 and plug it in there. 3 to the negative 1 power becomes 1 over 3. Is that right? So I get 1 over 3 minus 4. Well, that's equal to negative 3 and 2/3. That's kind of a yucky answer. Negative 1, negative 3 and 2/3. Do you agree that that green dot's about the right spot? All right. Let's plug 0 in. 3 to the 0. Or, yeah, 3 to the 0. 1. 1 minus 4. 3, so 0. Negative 3. So that's like about right there. Plug 1 and 3 to the first is 3. 3 minus 4 is negative 1. Plug 2 in. 3 squared is 9. 9 minus 4 is 5. Oh, good. Everything fit on this graph really nicely. I like it. Would you feel this is growth or decay? Growth. Why do you think it's growth? You're absolutely right. Yeah, as I go to the right, I go up. I like it. Mathematically, you could say as we go to the right, my graph grows away from the asymptote. That might be good. But you can say as it goes to the right, it is getting bigger. Okay. So basically, if I had watch how my pen goes. If I had this coming down like this, if I had a graph that was doing this, that's also growth. Okay? A lot of people are like, no, it's decay. So, no, it's growth. It's growth in the negative direction. But we're not dealing with that on that one. Okay. Let's see. What is the equation of horizontal asymptote? We got that right there. What is the rate of change from 0 to 1? From just 0 to 1? 0 to 1. So they just wanted this one. So again, remember slope equation. All right. Negative 1 minus 3. That's negative 1 plus 3, which is 2. And then 2 over 1. Okay. So from 0 to 1, we have this slope. And then they wanted to know what's this rate of change here. So 5 minus 1, so that's 5 plus 1, that's 6. And 1 minus 2, oh, that slope is 6. That's pretty steep. Cool. What do you notice about the rates of change? They're different slopes. If f at x is an exponential, is it growth? Or we already said it's growth. It's growth. Okay. And what is f at 2? Well, when I plug 2 in, what did I get out? 5. Good. Done. That page done? Feel good about it? Make sure your name's on it. Pass that on forward. Franny, how'd you do?
I don't know.
You want me to check?
No, I can check your name.
I'll check right now.
Okay. That's creeping me out.
Don't worry, I won't be up on the main screen.
Don't say out loud. I really forgot like what I was doing. You didn't know that?
I just read what I was on.
Well, I named it the same. You've never realized that?
Slow. I hate to tell you this, but
Did I actually?
something like 20 out of 28.
Okay, sweet. Thank you.
I look forward to a Franny.
I can't believe you didn't know that. That's why.
Oh, you know, sometimes I'm slow. You know that.
Yeah, that's like a whole year.
You know,
Stress.
well, Power School doesn't show your middle name. It's when I go on that shows your middle name. So,
Okay. Bye.
see ya. All right. Four. Do you have a Grateful Dead shirt on?
Yes. My dad and I are two main Grateful Dead shirts.
You're what?
My dad and I are two Grateful Dead shirts.
That's awesome. We had this conversation, I can't remember. Did we talk about Grateful Dead before, you and I?
Mm-hmm.
Okay. So you know my brother-in-law is like this. He's got the Grateful Dead tattoos, you know, the dancing bears.
Yeah.
He's got them all with that, and it's like down like this. But did I ever tell you my joke about the Grateful Dead tattoos? So I used to teach with a guy in Vegas named Joe Pribble. And I like to joke around. I don't know if you knew that or not. But I have science. So Joe, he was a heavier guy. And he would joke about, he would tell kids, look, I got my arms out so you can see that I'm walking and not rolling. So I told the kids, I said, ask Mr. Pribble. Actually, his PhD is Dr. Pribble. Ask Dr. Pribble about his Grateful Dead tattoos. And they're like, what? I said, and I showed him, I said, he has dancing bears, but he has them going around his waist. And he got it when he was 180 pounds. And now they have really long arms. The kids are walking, Dr. Pribble, can I see your Grateful Dead tattoo? He goes, what? I heard you have really long arms on the dancing bears now. I said, what? He comes like, sir, what are you talking about? Sorry.
Sure, can I go to the nurse?
Yeah.
Okay, thanks.
Sophia, I grabbed your homework off your desk. Is that okay?
Okay, thank you.
Yep. Okay, let's take a look. Did everyone get notes? Everyone have them? I'm sorry, I was off task. You know me. Did I get you guys notes?
Yeah. Yeah.
Okay. Oh, wait, we're frozen. Volume, no, freeze, yes. All right. Let's see. Appreciation, depreciation. Growing, losing value. Sound good? Growing and less than. You know, not growing. Like not standing still, losing stuff. Cool? All right. So think about this. It's $100. I know $100. Yeah, it'd be great to have someone give you a $100 bill. Probably make your weekend. Probably have some fun, right? Movies, pizza, Pop-Tarts, good stuff. But you decide to put $100 into a bank account, and that bank account earns 10% interest, and that's kind of though our interest rates in banks are coming up, boy, this would be incredible if you find 10%. But it says you earn 10% interest each year. How much money will you have after 5 years? So do you think you would have more money or less money? More money. That makes sense? Okay, so definite more money. Now, I have a question though. I have a question. Do you think your money would be worth $200?
No.
More than that?
Yeah.
More than 200? Could be. I don't know. Anyone think it's going to be worth more than $200 after 5 years? They have one. Anyone think it's going to be a little less? A little less? Okay. I bet you're right. So I bet you it's going to be more than, we'll have more than 100, but less than 1,000. Let's say that.
Oh.
Okay. So does that seem like an okay range?
Yeah.
Anyone think that it's going to be over $1,000? Because if it is, man, I want to bank at your bank. That'd be awesome. Okay. So more than 100, but less than 1,000. Seem okay? All right. So let's see what they're going to talk about. So they have this equation here, and I know there's an awful lot to this, and this is actually kind of a nice slide, but you know, as a 13, 14, 15, 16-year-old kid, you might look at it going, okay, there's more than one word. I don't want to read it. But the equation we're looking at is this. Y equals A, and then you have parentheses 1, which is a constant, plus R, and then you're raising it to the t power. So the final amount they're calling Y. The initial amount they're calling A. Your rate of growth in a decimal is R, and then t is time, and then whatever's in the parentheses, the 1 plus R, that's called your growth factor. Okay? What does that next slide talk about? So just go back to the 100. All right. So let's do this. Let's talk about that last problem. So a bank, I want to put $100 in. I'm getting, what did the last slide say, 10%? Is that what it said? 10% interest. And then we're doing 5 years. Is that okay? Oop, if I could spell, things would be good. All right, so this will be our time. Our initial amount is going to be the 100. And then I need to make this. How do I make 10% a true decimal? 0.10? Is that right? 0.10. That will be our R value. Okay? So we're making money, right? The interest is making money. Let's see if we can figure this out. So I'm going to do Y equals the $100. 1 plus, what is R as a decimal? 0.10, right? Raised to the T. We call T 5. Is that okay? All right. So I'm just going to pull up a calculator. Let's see if we can play this a little bit. And this will pretty much work on any scientific calculators. Just this is the one I have available for us. Hey, what is 1 plus 0.1? Is it just 1.1? Yeah. Okay. Let me clear this. Okay. What? 100. So I have 100. And then I have 1 plus 0.10. And it's raised to the fifth. All right. So between 100 and 1,000, is that what we said?
Yeah.
We all feel good. It's got to be better than 100. And probably less than 1,000. Okay. Ooh, $161.05.
I got 159.841.
Dude, did you put it in the same way as me?
No, I just did it the more complicated way.
How'd you do it?
Well, I took 10% of 100 and then I added that 10% to 100 and then I took 10% of 110, which is 11, and I added that, so I got 121, and then I did that over and over and over.
So you did 100 times
No, divided by 10.
divided by 10.
And then I added that, and I added 100 to 10.
So you went 100 plus 10, and then plus 110 plus 11?
No, not 100, not plus 110, because that gets you past 200.
Oh, okay. Huh. Interesting way to do it. You're pretty close. So you had 159?
I got 159.84.
Wow, pretty close, buddy. Huh. I like it. Good thinking there, bud. I mean, you're off a smidge, but I like your thought process. All right, so let's move on to smidge. Let's see what happens here. The inaugural attendance of an annual music festival is 150,000. The attendance increases by 8% a year. Wow, 150,000 people at a concert or a music event? That's a lot of people. Okay. So we have 150,000 people that show up to this particular event, and it increases by 8%. Hey, how do I make 8% a true decimal? 0.08? Is that okay? All right, so write an exponential growth function. So we're getting more people, so I'm going to go 1 plus the 0.08. So I have y equals a 1 plus r raised to the t. So I'm going to have y equals 150,000. Man, that's a lot of people. Plus that. Okay, and then after t years. Cool. So that's our equation. And then how many people will attend the festival after the 5th year? So where am I going to plug 5 in? And for t, cool. All right. So y equals 100. I couldn't imagine what 150,000 people look like. Man, that's a lot of people. Cool. I'm going to do this on the calculator. There we go. All right, so I'm going to do 150,000. One more zero. 1 plus, how much did it increase by? 0.08? It's not 0.8, it wasn't 80, it was 0.08? Okay. And then we want to know after 5 years. So, more than 150,000 people will be there? Agree?
Yes.
Okay. Holy cow. 220,000 people? Now, so this is where sometimes it's hard to wrap your mind around it. 220,399. How do you make 0.2115 of a person? You don't. Yeah.
Okay, I don't know. I'm not being missing something. But how come when 5 is up there, it only goes to 160 mark? When it's on a bigger number, you gotta see
Yeah, because the 1.08 it's taking 1.08, going 1.08 times 1.08. So you're talking about a small number, right?
Don't we have to divide by 5 for each year? Because you.
That's after that.
Exponent.
That's in the 5th year.
But it says every year.
Whoa! Did I miss? Whoa! All right. How many people will attend the festival in the 5th year? In the 5th year.
Oh.
So the 5th year. So like if this was this year, then 5 years from now is 24. It's 19, right? I still feel like it's 2001, but. Okay. All right. A website has 500,000 members in 2010. The number of Y of members increases by 15% each year. Okay. So again, I'm going to use this equation. Oops. Let's go back to this. Y equals A 1 plus R raised to the t. It's 500,000. That's a lot of people. That's more than our concert. All right, 1. Hey, what's 15% as a true decimal? 0.15, right? Good. Plus 0.15 raised to the t. How many members will they be in 2018? So 11, 12, 13, 14, 15, 16, 17, 18 after 8 years? So I'm going to plug an 8 in for that. 500,000. 1 plus 0.15 raised to the 8th power. Yeesh. So there could be more than 500,000, right? All right, let's see if we can do this. 500. 1, 2, 3. 1 plus what? 0.15. Okay. Raised to the 1,529,511. And that poor person, that's 0.431 of a person. They must be missing a leg or something.
Probably a bot.
A bot. So we would round that to the next number. So 1,529,511. We doing okay? All right, so then we go to the decay model. So the difference between the growth and the decay is a subtraction sign. So this sign right here is the only thing that changes. Okay? And you would call that your decay factor then. So let's see if we can build upon that. So the value of a car is 21,500. I don't know what kind of car it is, but let's just pretend. It loses 12% of its value every year, so it's worth less each year. So I'm going to turn 12% into 0.12. And I know this. Y equals A1 minus R raised to the T. So that's the only difference. I made that a subtraction sign. All right. Sometime. So that's our equation. Estimate the value of the car after 6 years. So where's the 6 going? Into what? For T?
Yeah.
Cool. So the car's worth less?
Yeah.
Do you think it's less than 10,000? I don't know. Let's see. 21,500. 21,500. 1 minus. How much did it lose? How much? 0.12? 12%? Really? 12%. Jeez. And we'll raise that to 6 years? Anyone think it's less than 10,000? It's going to be less. Oh, it is. $9,984 and I guess rounded to the nearest penny, 69 cents. Do cars lose value? Yeah. Do they start increasing in value? Yeah. But the hard thing is, a lot of people will have their car and they drive it every day. It's kind of hard to say, hey, this 30-year-old car is increasing in value if the person was driving it every day because it's got a lot of wear and tear on it. But not to say that it wouldn't go up in value, but it would. It could. All right. Determine if it's growth or decay or neither. So this one, it looks like it's going down by, we're dividing it by 3 each time. I'd say that's decay. I like that. That's a good call. And this one goes up 5, then 10, and 20. I'd say that's growth. You feel okay about those? All right. How many more slides I got left? That's okay. All right, then this one, let's see. 64 to 16. There to there is divided by 4. There to there, I divide by 4. Did I divide by 4 there?
Like someone fooled the clock.
What did I do?
It's on 45 already.
Oh, I've been off task. Sorry. Divided by 4, so I'd say this is decay. And then 3, I add 3 I add 7. No, that's a neither. All right. So decay, growth, decay, neither.
Wait, no,
Woo! This is glowing. This is glowing at me. I don't know about y'all. All right, determine that each function represents growth or decay. So that right there is bigger than 1, so it's growth. And identify the percentage of growth factor. So this is going to grow by 107%, or 1.07. So that's our growth factor. And then this one is decay. The reason it's decay is because it's 0.98. So it's going to be worth 98% each year, or 0.98. All right. What do you guys want a lot of homework this weekend?
I mean, I get.
no,
Joke. Oh my god.
L, no.
How about page 165? Page 165 and 166, and you're going to see that 166 is blank, and so there's only 5 problems there. Cool. Good period. I gave you guys all the review, right? Everyone has the review page? Okay. Good job, everybody. Get out of here. Take care of one another. Have a great weekend.